So in this video, we're gonna go through the setup of um, final IK asset with our humanoid. So what you want to do is add this to the project, which I already did. It just says add in the project, and what's in the project says it's in the project. So it's added. And then we're gonna go to inspector. Then on the controller side, we could have the VRIK animated locomotion, which basically means it'll use the VRIK packages animation in order to animate the humanoid, which is what we need. So in this video, I'm just gonna go through the setup. Later on, I'm gonna probably have videos explaining the code too. I'm not sure exactly what I'm gonna do here. So here I'm just gonna VRIK manager, add a component called VRIK tracking mirror. I don't know what it was. Actually, I created a new file. So I'm gonna copy and paste some scripts from that I was working on a different project into this project. So that would be from Meta. You, this is wrong. This is wrong. Not what I want. Unity Games, the meta calibration, which is on an older version of the Unity that we're not going to use anymore, but we need. And then we have the upper limb tracking. So in the scripts here, in the assets, we have a scripts folder. And under here, again in assets, and scripts folder. I'm gonna duplicate some stuff, which should be okay. I was most recently working on this, so I guess this is it. Quest. IMU receiver. Nav the IMU monitor, maybe. Anyway, this is beyond the point that I was trying to make. So here, so now that we copied the scripts we wanted, it's now actually building those C# scripts. And if there were any errors associated with them, you would see them in the console here. But now we go to the scripts. Okay, so I'm gonna add a VR mirror tracking here. And briefly, let's open up the script. here. And what we'll see is setting it up. We're basically using this manager to set up our VRRK, set up where the humanoid will be in the scene, and telling the humanoid that it's going to mimic us while having an offset of a distance from the player, which we set it to be 2 meters. So it's going to be 2 meters from me, and it's going to start mimicking my hand motions. And in terms of hands and head motions, so I am giving it targets, head, hand, or hands, and it will use either the controller or the hand, whichever is active, in order to do the hand tracking. Okay, so if it's so we are using the center of the eye anchor for head tracking, and for the hand tracking, we are using the hand anchors, which we'll set up in the Unity. But the important part of this script, I guess, is the fact that we are setting up the mirroring effect, which means we are defining a mirror in a sagittal plane, and as a result, when we are setting up the anchors, then the targets that we are giving to the humanoids needs to be mirrored first. So we're going to do some transformational math here, which is really just doing the mirrors in against that sagittal plane, and adding the offset, distance offset, and setting the new world quaternions into, so if I'm doing the right hand mirror, into the left hand of the humanoid, and vice versa if the mirroring is on. So here in our humanoid, we are going to add the VRIK. So it automatically populates our humanoid, various things, structure. But what's important is that it actually puts this as the root of the humanoid, and you see like the humanoid, all the bone structures and everything is set. But what we want to actually change is that instead of putting the root of the humanoid to be this, we're going to actually put the root of this setup. And what it really does is that we are defining all the bone structure of the humanoid under the root. And as you can see, if you put on the root, it goes from the 0 at the foot of the humanoid, right? And then the humanoid center is at the pelvis. It's just, yes, makes things easier when we are doing the mass transformations, knowing which transformation we are applying things to. So I want it such that when I have the root of the humanoid, all the bone structures and everything is defined with respect to this root, which I don't want to miss any of those. But when I want to move the humanoid in 3D space, I want to use this reference. So here, the robots transformation, we're gonna actually use the robots transformation. And then the VRIK is the one that is attached to our robot, which we only have one, so we use that. Then we use the camera rig to put the camera rig here. And why you want to have a camera rig here is that when you're doing these sagittal frame transformations, you don't actually want to use your center of eye. You want to use your camera rig's transformation. Sorry, not transformation, the transform in order to define the sagittal plane. But when you actually want to track your head, you want to use center of eye tracking. And then we're gonna have the left hand anchor and the right hand anchor. Now defining the targets. So these are the targets is basically is trying to keep track of our tracking that we want to do on the human, and then it gets those from me and then puts it onto the robot and gives robots some targets that it uses to solve the inverse kinematics of the robot. And it doesn't matter what their initial value is, because we are actually getting them and constantly updating them by reading data from these anchors, applying the math in order to mirror and set it into our offset of 2 meters in front of us and doing the mirroring. So in the past, I put them out here. So we're gonna define, no, okay, what I'm trying to say is we're gonna define those targets by creating empty objects and call them the head target, not heat target, but head target, left hand target, and actually we just duplicate this and rename, which doesn't matter. Call it the right hand target. So my issue is that I really don't know whether I should put them in under this transform or leave them outside. When I did the testing, it made sense at the end to put them inside the humanoid, because the reasoning was that wherever the humanoid is, it just multiplies the humanoid's overall transformation in 3D space. And uses targets in relation to that. But with that, I guess let me just double check something. But we already are adding this distance here as well. So in a way, it might be redundant. Anyway, we'll do test both and see what works and what doesn't. So now that we define these, we add these here. So we have them. And what are these? We just gonna set everything to 0. so that there are no discrepancies. Although, even if we don't set them to 0, they should automatically all go to 0 once we set them up. Now we are going to VRIK, and in our solver, we are saying the head target. So remember, in the code, in the VRIK manager, we are actually reading the head, these anchors values, applying the mirroring math, and then writing them into these targets transformations. And then we're gonna go to locomotive motion and actually change this to animated. These are a bunch of settings that we gotta play with to figure out later. But what's important here is to make sure that these position and orientation, so position and rotation weights of the targets are 1, meaning that it really reads those data. What I mean is like it 100% uses the heads and hands and the heads controller to do the inverse kinematic and accurately track the real-time position. The only other component I'm gonna add is the VRIK calibration. This is just a simple script that uses the center of the eye to the ground that it detects and scales the humanoid automatically such that its height matches that height from your center of eye to the ground. So that the humanoid is approximately your size. And our head target is center eye anchor. All right, so we save and build and run. And I am entering the game. Okay, good. Humanoid is here. My height. And nothing is happening except that it's following my head. Yes. Yes. Okay, head is good. Rotation around the wrist is good. I mean, relatively good. And then we don't have the hand movements at all. Do we? Nah, we don't. Kinda, we struggle. Okay, putting the controllers away. Hands activated. Again, the wrist rotations there. Heads there. And then the hands are there. If you look at my hand, you're stuck with it. Okay. So this is what we got for now. Oh, one thing I want to test quickly before the end of this video is if we put these under this and save. And the other thing I want to actually show, which I don't quite understand, but it works quite well when I change the setting of it, is this business here of the curve. Okay, so for him, we want these to be 1. We want the shoulder rotation weight to be around 50%. Shoulder allows shoulder to react without over rotating. Okay. So shoulder rotation mode, yaw pitch is the best for humanoid shoulder arc. Okay. Shoulder twist weight between shoulder twist weight between 0.3 to 0.6. Let's put 0.5. Apparently adds realistic upper arm roll. Shoulder yaw offset. Adjust forward bias of arm reach. Shoulder pitch offset. Negative 10 to lower. Negative 10 to negative 20. Seems to be a good range. So we'll do negative 15 on that. And then the bending suggestion. Slightly to empty. Gain object slightly to side of form. Define elbow direction. So the bend goal defines the elbow direction. What does that mean? Like if you're like rotating, maybe twisting, it means something. Bend goal weight of 0.4 to 0.8, which let's say 0.5, helps control the elbow drift. Okay. Default linear keeps motion. So this, the default is linear. Let's use these for now. And let's do it on a single arm, which is our left, and compare it to our right. And as I said, I put these under my humanoid, which to me doesn't make sense because already in the code, I am calculating the distance from me to the player that I've already set in the VRIK manager and multiplying it that with all the other mirroring math that I'm doing and setting my targets to those transformations. So to me, I am not supposed to put these under the humanoid transformation because I am already calculating that in my script. But we'll see how the code will work this time around. And once that's done, I am going to be doing the testing. Which means I gotta cast again, and I'm waiting for this. Oh, it's already copying. Yeah, we didn't change much, so the build this time round is faster. But I guess the copying takes a while, so I'm gonna check on my 3D printer. It's 19%. Ah! Okay. Back to the game. Okay. The reason my humanoid is not here anymore and it's here is because it uses that initial position of my headset to set the humanoid 2 meters ahead of me, and then the script doesn't update. The humanoid is rooted there, so it doesn't move anymore after that. So that's why it's there. So as you could see, we changed some of the variables for the ref arm of the humanoid, and it has more motion, like slightly more than the right, it seems, right? Or am I just hallucinating? No, I think it does have more motion than the right. And so let's see. See, nothing changes, which is so bizarre to me. It doesn't matter where I put the target, under which transform, it is still does the same thing. Which it shouldn't. It shouldn't consistently work, you know, at some point. One of the two options in my head should mess up the calculation, but it seems like it doesn't. Can you not detect my hand, please? I don't know why. Sometimes it just doesn't. You see, okay, this one moves a lot more than this, right? Does it really? Yeah, kinda. It does move the shoulder. Whereas you see, the right hand of humanoid, the shoulder is locked. But the left hand, the shoulder rolls, it seems. Um, yeah. Yeah. This is all we have to show for this video. So open questions to be solved by me or figure out is why having the head targets here still works, because in my script I measure the offset, put it in. So in my head, the only way it makes sense is that if these targets are outside in the overall scene, and I'm constantly writing to them the position I want them to be. And in my head, they should not be under the humanoid. But somehow it makes no difference if I put them under the humanoid or not, they still function the same. That's one. More questions is what optimal setting would work, and how much we can improve this inverse kinematics using IMUs. So stay tuned.